Okay, so let's unpack this. We're doing a deep dive today on what looks like just a product sheet. It's for the NTI SM-32X8-15V-LCD VGA video matrix switch.
Right.
It sounds super technical, maybe a little dry, but I think our job here is to figure out why this exact kind of gear is, the secret central nervous system in places like command centers.
Yeah, that's a great way to look at it.
Hmm.
Our mission really is to turn this part number into, well, into an understanding of how mission-critical video gets managed.
Okay.
We're going to see how this one box solves a really complex problem, taking video from, say, 32 different computers and routing it instantly to any of 8 different screens. It creates this true information matrix.
So the core of it is the routing, 32 inputs to 8 outputs. But the big takeaway, it seems, isn't just switching one to one. It's that you can take one computer's video and blast it to several monitors at the same time.
Exactly. It's all about making sure everyone in the control room sees the same thing at the same time. Total consensus.
And that consensus really depends on the signal, right?
It's everything. When you split a video signal that many times, degradation is your biggest enemy. So this NTI switch uses buffering.
Buffering. What does that mean in this context?
It means each video output gets its own dedicated private lane from the input source.
Mm-hmm.
The signal isn't competing for bandwidth. It guarantees it doesn't get weakened by all the connections.
And the result I'm reading from the source here is the image stays as crisp and clear as if directly connected to the original source.
And that's the benchmark. That's what you pay for in a professional system.
Absolutely. Okay, let's address the elephant in the room here. VGA, it feels like an older format, but the performance specs here they're not old at all. We're talking 1920 by 1200 resolution.
At an 85 hertz refresh rate, yeah. That's pretty demanding.
So why VGA in, the modern era? We have HDMI, we have DisplayPort. Is this just about saving costs, or is there an engineering reason for it?
It's definitely engineering. It's all about reliable long-distance transmission over standard, easy-to-run cables. The NTI design gets that 200 megahertz bandwidth, but it does it while driving standard VGA cables.
Ah,
So you don't need these expensive signal extenders or those really bulky old-school coax cables with the BNC connectors that were a nightmare to install.
So sticking with VGA is actually a move for simplicity and proven resilience in big professional setups.
Exactly. And speaking of simplicity, the control options are incredibly flexible.
Right. I was looking at that. It's not just one thing.
No, you can control it right from the front panel's LCD screen, or you could do it remotely through a serial port or even Ethernet.
And they include software too, right?
They do. The Matrix control software gives you a full GUI, a graphical user interface. So you can literally just drag and drop sources to displays on your computer screen.
That's pretty convenient.
And for, say, a boardroom, it even comes with a little infrared remote. Super simple for quick changes.
So now that we get the tech, let's connect it to the real world. This isn't something you'd buy for your home office.
No, not at all. This VMUX switch is built for places where failure just is not an option. Think command centers, big corporate boardrooms, hospital control rooms, or massive digital signage setups.
That makes sense. And that's probably why they emphasize the testing so much.
It has to be. The sources point out that every single unit goes through a minimum 24-hour burn-in.
Wow.
Yeah, and heat testing. And they load test every single port before it ships. They are selling reliability above all else.
We should also touch on the regulatory stuff. I see CE, OROHS, and TA compliance.
And TA is a big one. It means the product is made in the U.S. or a designated friendly country. For any U.S. government contract, that's often a deal breaker. It's a non-negotiable requirement.
So this whole package, the testing, the compliance, the solid bandwidth, it just screams reliability. The NTI matrix switch is a perfect example of why guaranteed signal integrity is so crucial in these high-stakes environments.
It is. And it makes me think, leaves a question for you, our listener. If a piece of hardware this critical needs a 24-hour burn-in test to be trusted, what's the equivalent of that test in your own professional world? What's that one process or piece of information you need to be absolutely certain about before you act? It really makes you think about what it takes to achieve that kind of zero failure tolerance.